Here we have a problem on arithmetic sequence. Okay, let's go to the question. If 9 times a ninth term of an arithmetic sequence is equal to 15 times a 15th term, so that 6 times a 24th term is 0. Okay, it is given that is 9 times a ninth term. We can write 9 times a9. It is equal to 15 times a 15th term, that is a15. Actually, this a9 represents the ninth term of the arithmetic sequence, and this a15 represents the 15th term of the arithmetic sequence. According to the information, 9 times the ninth term equals to 15 times the 15th term. Okay, now we have to find, we have to prove that 6 times the 24th term is 0. 6 times, that means 6 times a24. A24 represents the 24th term equals to 0. So this is a result we have to prove it. And also there is a formula to get nth term of an arithmetic sequence, that is an equals to a1 positive d times n negative 1. Okay, using this formula we can write the stuff for a9. So let me continue over here. That is, and also before that, what we can do is we can divide both sides of this equation by 3, because both 9 and 15 have the greatest common divisor 3. Okay, so let me divide both sides by 3. So this 3 goes into 3 1 times, and 3 goes into 9 3 times, and here 3 goes into 3 1 times, and 3 goes into 15 5 times. We get 3 times a9 equals to 5 times a15. Okay, now we can write expression for this a9 using this formula. Okay, so when we have an, that is equal to a1 positive d times n negative 1, then what can we write for a9? So comparing this an and a9, we get 9 at the place of n. So in this expression, we have to plug in 9 for n to get the stuff that is equivalent to a9. So then I'm getting a1 positive d times, we get 9 negative 1. The same thing we have to do on the right side as well to get the stuff which is equivalent to a15, that is a1 positive d times. Okay, now since we have 15 over here, we have to plug in 15 for n over here. Then I'm getting 15 negative 1. Okay, then we get 3 times a1 positive, 9 times 1 is 8, 8 times d can be written as 8d. Let me write it. And 5 times a1 positive, 15 negative 1 is 14, 14 times d is 14d. Okay, now we can distribute this 3 to a1 and 8d, then I'm getting 3 times a1 positive 24d. And here we can distribute this 5 to a1 and 14d, then I'm getting 5a1 positive 70d. Okay, now let me take the same equation over here. That is 3a1 positive 24d equals to 5a1 positive 70d. Okay, let me subtract 3a1 from both sides, and also let me subtract 24d from both sides to get all the terms on one side of the equation. Okay, so when I do so, this one will cancel out, and positive 24d, negative 24d will cancel. We get 0 on the left side. So here on the right side, when I combine positive 5a1 and negative 3a1, I'm getting positive 2a1. And here when I combine positive 70d, negative 24d, I'm getting positive 46d. Okay, for my convenience, let me write this stuff on the left side and 0 on the right side. That is, I'm going to switch these two quantities, and I'm getting 2a1 positive 46d equals to 0. Okay, here when I consider this one and this one, both the terms have the greatest common divisor 2. So we can factor 2 out. When I factor 2 out, I'm getting a1 in the first term and 23d in the second term. So that is, to get the terms inside the parentheses, we just have to divide both the terms by the one I factor out. When I divide this one by 2, that is factor out, I'm just getting a1. When I divide this 46d by this 2, I'm getting 23d. Okay, now let me divide both sides by 2. Then I'm getting this 2 will cancel out. I'm getting a1 positive 23d equals to 0 divided by 2 is just 0. a1 positive, and we can write this 23d as d times 24 negative 1 equals to 0. Okay, now let's consider the expression we have over here. That is a1 positive d times n minus 1 equals to an. Actually, so this is the expression equivalent to nth term. Okay, now let's consider the expression we have over here. It's exactly in this form. Okay, here we have a1, here we have a1, here we have d, here we have d. At the place of n, we have 24. When you have n over here, it represents the nth term. When we have 24 over here, then this must represent 24th term. That is, it can be written as 24, a24 equals to 0. Okay, now I got the value of the 24th term on the given arithmetic sequence. Okay, we have to prove that 6 times 24th term is equal to 0. So let me take 6 times the 24th term, that is 6 times a24 equals to 6 times. Already we got the value of the 24th term, that is a24 is 0. We can plug in 0 for this a24, that is 6 times 0. Then we get 6 times the 24th term, that is a24 equals to 6 times 0 is 0. Okay, now I have proved that 6 times the 24th term of the given arithmetic sequence equals to 0.